In this video, we're going to look at coterminal angles and see maybe different ways that we can find coterminal angles for both degrees and radians. Now, the biggest thing about these coterminal angles is that we developed our unit circle, the degrees and radians, the other day. And if we look there, 510 is not on that unit circle. Negative 690 is not on that unit circle. So we're trying to find the degree measurements that actually do fall on our unit circle. Now, if you were here the previous class, we talked about like numbers 1, 3, and 6. That if a degree measurement is bigger than 360, so like if we have on our coordinate plane, if I go around the circle once, that's 360 degrees. So if 510 is bigger than 360, I can take that 360 and subtract. Because I need to take away what we already went, and then that's going to tell me how much further to go. And so the coterminal angle with 510 that falls on our unit circle is 150 degrees. Similarly, we can do something similarly here with 480 and get 120 degrees, which is on our unit circle, and 60 degrees here. So those are what we call coterminal angles. The good thing here is that we can find the degree measurements that actually do fall on our unit circle, which is what we want. Now, if we want to do that for negative angles, then we can do that something similar. But if it's negative, some students said, like here for 690, instead of subtracting, maybe add 360. Well, if we do that, then if you do negative 690 plus 360, that would give us negative 330. But if you look, negative 330 isn't on our unit circle either. So what students said is, what if we add 360 again? Which we can do, because it's just going around the circle again. Then that would give us 30 degrees. So what this is telling us is that negative 690 and 30, they both fall on the same spot in terms of our unit circle. Okay. We could do the same thing here for number 5. If we have negative 30 or negative 45, we add 360, that would give us 315. And so that's the angle measurement that falls on our unit circle. Now, another way we could think about it, some students said, like for example, if I want to do negative 45, well, we know if we start here on the positive x-axis, if we rotate this way, that's the positive direction. So if we rotate the other way, that would be the negative direction. And what some students noticed is if we go in the positive direction, this would be like 45 degrees. If we go in the negative direction, the same amount, that would be 315. And so we get that 315 in both cases. Either way is, they're both correct. We're going to continue doing coterminal angles and talk about that, but we did talk about positive and negative in that light. Now, I could go through this. I'm going to go through one way on numbers 1 and 2. I'm not really going to do 3 and 5. We're going to continue to do coterminal angles a lot, and I'm going to talk about the different ways in class. So if you have questions on those, please feel free to ask. But if you weren't here, let's think about this negative pi over 6 in this light with the rotation. Well, if I look at positive pi over 6, that's like me rotating here. That would be pi over 6. But if I rotate in the negative direction, this would be negative pi over 6. A little hard to read, but negative pi over 6. And if I look on my unit circle, pi over 6 was there. Negative pi over 6 falls in the same place as 11 pi over 6. And what students said about negative angles, if we can find, so like for example, if we have negative 5 pi over 4, well, we can see that 5 pi over 4 is here. To find the negative 5 pi over 4, we reflect across the x-axis. So this would be negative 5 pi over 4, or on our unit circle, 3 pi over 4. So to find the negative, if we want to think about it in radians, to find the negative, we can locate the positive version of that angle, reflect it across the x-axis, and that'll give us the negative. All right. But I also want to talk about, if you need to pause, rewind, that's fine. Please feel free to do so. But I also want to talk about 11 pi over 4 a different way. So 11 pi over 4 now on our unit circle. It's going to be bigger than 2 pi. So what some students said is, hey, here we had something that was bigger than 2 pi, and we subtracted 360 to find the coterminal angle. So what if we did the same thing here, but instead of subtracting 360, we subtract 2 pi, because 360 in terms of radians is 2 pi. And we can do this, but we have to be careful because we have a fraction here. I'm actually going to make 2 pi a fraction, put it over 1. And hopefully, if not, it's okay, but hopefully we can remember, in order to subtract fractions, we have to have a common denominator. If we're adding or subtracting fractions, we have to have a common denominator. And if we get a common denominator here, I want to have 4. So if I multiply this 1 by 4, then 1 times 4 is 4. I have a common denominator. But whatever I did to the bottom, I have to do to the top, because 4 divided by 4 is 1. And so I'm not actually changing the value. Okay. And then we can go ahead and do this. So 11 pi over 4 stays. If I multiply these two fractions, 2 pi times 4 would give us 8 pi. 1 times 4 is 4. Now we have a common denominator. That stays. 11 pi minus 8 pi would give us 3 pi over 4. So what we're saying here is that 11 pi over 4 and 3 pi over 4 are coterminal, and this is helpful because 3 pi over 4 does fall on our unit circle, and so we can locate that quickly. If you have questions about coterminal angles, hold on to them, bring them to class, because we will talk a lot more about coterminal angles as we continue going through these functions. I'm going to stop this video now. The next video for today, we're going to look at how to develop the unit circle and the actual ordered pairs for at least some of the ordered pairs on our unit circle.